Okay, question 4 is for reaction rates for organic. A lot of this is going to be theory. So the formula of the catalyst, this was the ester preparation. You did this as a prac. This was the, fart cheese prac. And the catalyst is concentrated sulfuric acid. So I don't know whether you remember, but when you did your practical, they didn't give you the mark unless you said concentrated. So you maybe want to put in concentrated in case they are stricter when you do your prelims. The type of reaction, it's an esterification reaction. You can also call it condensation if you want to, because it makes water. So because the reaction makes water, it's sometimes called condensation, but I do think esterification is a better name for it. But you're making an ester, so it kind of makes it easier, I don't know. 2 reasons why the water bath is preferred in this experiment. Again, this entire question is basically based on your practical that you did in February or March or whenever you did it. The alcohol, the methanol, the reactant is flammable. So you need to be specific and not just say, it's flammable. What is it? You must try and be specific. So you need to say the reactant is flammable. So you don't want flames near it if it's going to catch on fire. I don't know what I've just done now. Anyway, we zoomed out for some reason. Then the other reason is to heat it evenly. So the water bath helps you add heat to the entire contents of the test tube all at once. So that is another option. And then the third option that they gave was it's volatile, so it might evaporate if the heat is too, like a flame would be hotter than a water bath typically. And so then the alcohol might evaporate and then the experiment can't happen. So we need 2 reasons. They would probably also eventually start accepting stuff about safety maybe. So like it's safer to do it in a water bath than with a flame. But anyway, so just remember that in case they ask you. You do need to be familiar with the esterification reaction specifically because it is a prescribed prac in grade 12. Then they want the balanced equation for the reaction using structural formula. This I think I'm going to do in a pen for you quickly. Methanol is a 1-carbon alcohol. So it's just that thing. And then propanoic acid is a 3-carbon acid. So you must just remember to always add your H's and make sure that every carbon has 4 bonds. Now, to do the ester part, we start with cocoa. So we start with the cocoa. Make sure each carbon has 4 bonds, and then we can see here that the acid half has 3 carbons. So we need to do 3 carbons on the right-hand side of this oxygen, and this one only has 1. So that's the only carbon on the left-hand side. And then we have to add the hydrogens, and that over there that I've drawn is methyl propanoate. That is methyl propanoate, and the other thing that you make is water. So again, this is exactly out of your practical that you did. You really want to try and Google the prac just to run through it before you get to your prelims. And that's exactly what I drew for you, more or less. This is a bit neater, but you can see the cocoa bond, and it's 3 carbons on the side with a double bond O, and 1 carbon on the other side. And then they want the name. It's going to be methyl propanoate. Okay, so there's the name of that thing. It's 1 carbon alcohol and 3 carbon acid, methyl propanoate, for 2 marks. 1 mark each for each word. Okay, so here's the flow diagram type part for the reaction rates for organic question. And for this first part, they say that compound A is a 6-carbon branched haloalkane. So basically, compound A is this thing with one of the hydrogens being a halogen instead. So basically, compound A could be 1, 2, 3, 4, and then we can put a Cl or a bromine or an iodine or whatever over there. So this is what compound A should look like. The chlorine could strictly be on either side. I'm just putting it there. And then they tell you that reaction 2 is an addition reaction, which means that compound B must be an alkene. Addition reactions start with an alkene. Elimination reactions make an alkene. So this reaction over here, reaction number 1, is elimination because it made an alkene, and reaction 2 is addition because it started with an alkene. All of the reactions are all about where is the alkene. Addition has an alkene reactant, elimination has an alkene product, and substitution has no alkene. There's no alkene in a substitution reaction. So from that information, 4.2.1, the name or formula of the inorganic reactant in reaction 2. The elimination will eliminate the Cl and it will eliminate a hydrogen. Sorry, not the Cl. It will eliminate a halogen and a hydrogen. So this elimination reaction is dehydrohalogenation, whatever the halogen needs to be. And then what you've replaced it with is hydrogen. So the inorganic thing that you use in reaction 2, the inorganic stuff that you add onto compound B is hydrogen. Sorry, it's hydrogen. See there? Okay, then they ask you what is the name of compound B. Now compound B would be the same as compound A and the same as compound C, but it would have a double bond. The elimination happened and removed the halogen and the hydrogen, so there will be a double bond there in this thing. And it is 1, 2, 3, 4 carbons long in the green numbering, or it is 1, 2, 3, 4 carbons long in the red numbering. So we have dimethyl, and if we use the red numbering, it's 2,2-dimethyl, but then it's 3-ene, because the double bond is on the third one with the red numbering. If we use the green numbering, the dimethyl is 3,3, but the ene is on the first carbon. The ene is on carbon number 1, so this is the better numbering. This is the chosen numbering, because if something changes the last word in the name, if something changes the name of the parent chain, it is always a higher priority than the stuff that's added on in the front. So the ene is more important, so the name is 3,3-dimethyl but-1-ene. We use the green numbering because the ene needs to have the lowest possible numbering, and the red is 3 and the green is 1, so the green numbering wins. They are asking for 4.2.3, what type of reaction is reaction 1? We've already figured it out. It's an elimination reaction, or specifically they're saying dehydrohalogenation. Now, for the next part, they are going to take compound B. So if I can just delete all of this quickly. Compound B, if we remember from what I drew earlier, compound B is the one with a double bond in it. We named it. So it's this one. That is compound B, and they tell you that reaction 4 is substitution, and you end up making compound A, which is this thing again. And it's got, oh sorry, not the double bond, sorry. Compound A is a haloalkane, and it's got, I'm just going to put the Cl there again. So with Markovnikov addition, it is a Markovnikov addition. You must put the Cl on the carbon with less hydrogens. The hydrogen goes to the carbon that already has more hydrogens. So at the moment, this one has 3 hydrogens and this one only has 1. So the hydrogen that you're adding goes to the carbon that already has 2 hydrogens. The hydrogen gets added to the carbon that already has more hydrogens. The hydrogen gets added to the carbon in the double bond that already has more hydrogens. So the hydrogen gets added to the carbon that already has more hydrogens. So you can see here This one has 2 hydrogens, this one only has 1. So the hydrogen that we're adding goes to the carbon with more hydrogens. Substitution reaction, what we must have had beforehand. How do I make a haloalkane with a substitution? Compound D must actually be an alcohol. Compound D must be an alcohol. So exactly the same in every other way, but the substitution reaction is called halogenation, or halogenation of an alcohol. The substitution reaction, that is reaction 4, has no alkenes in it. It starts with an alcohol and ends with a haloalkane. There are no double bonds involved in that reaction. And we know that compound B had a double bond in it from the previous question. And so that means that compound B undergoes an addition reaction to make compound D. And what we've added is water. That reaction there is hydration. So when they ask you for 4.2.4, what is the name of the catalyst? It's H2SO4. H2SO4 is the catalyst for the hydration reaction. They then ask you for the IUPAC name of compound D. It is an alkane with an alcohol on the second carbon. And sorry again, let me do that properly. 1, 2, 3, 4. Or, if I use the green numbering, 1, 2, 3, 4. This is more important than the methyls, because the methyls are added onto the front of the name. It'll be 3,3-dimethyl, as long as the butan 2-ol gets the lowest number. So it should be 3,3-dimethyl butan 2-ol. The part that changes the main last word, see here, the thing that ends up changing the parent chain name must have lower number than the stuff in the front, because it has a higher priority automatically. That's what they decided, and so that's what the rule that we follow. So the IUPAC name of compound D is 3,3-dimethyl butan 2-ol. The type of reaction for reaction 3, we got that already. It's an addition reaction. We're adding water, so it's hydration. And then the type of haloalkane represented by compound A, it's primary, secondary, or tertiary. So for this, once again, we must just be a little bit careful. The carbon that the halogen is attached to how many other carbons. So the carbon that the halogen is attached to 2 other carbons, which should make it, they should say it's secondary. So the carbon that the halogen is attached to 2 other carbons. So that's it for this one.